So my name is Dehmer. I'm with Dark Horse Woodworks. We're an Atlanta-based shop. My shop's about 1.5 miles, 2 miles down the road from here. I've had my router for about 16 months now. We've been cutting on CNC for about 4 years, but we outsourced before we switched into having it ourselves. The reason I'm standing here instead of sitting there is we, of course, did some prep stuff and video call. And I'm listening to these guys go on, and my first thought was, what the hell are they talking about? And why am I on this panel? Because all I ever do is call them when I need to know how to do something. So I decided I would just moderate it, kind of stand in the back, and then when they do start getting too deep into the weeds and I see people dozing off, I'll stop them. At least that's the plan. So that's my machine. I have a 5x10. It's a Cam Master machine. We've got a 16-horse vacuum pump attached to it. We cut with Cabinet Vision and Aspire are the two pieces of software we use. We're not a high production shop, but we can get 35 sheets out of it in a day if we really, if the guys aren't taking forever to offload. It was a big jump for us, and it's changed how we do business, no doubt. Leland, it's your turn now.
Thank you. Good morning. My name is Leland Thomasset. I'm the owner of Taconic Woodworking. This is a picture of our machine. It's an Omnitech, which is an Anderson router. Again, very similar to Chris's. It's got a moving gantry versus a moving table. It's a 5x10 with a 10 horsepower vacuum pump on it. And this one has a dedicated drill block on it as well. Welcome.
Nice job.
I like that. Pulled it off. I'm Matt Krig. I'm from Minneapolis, Minnesota. Our company is Northland Woodworks. It started back in the late 70s. It's a family company. My wife and I have owned it for about 5 years now. That's our machine. It's a Como 5x10. It's, I guess, a big iron machine. At the time, Como was only about 45 miles from our shop. So when we bought the machine, it wasn't part of the arrangement, but they asked if they could bring people through. So they would pick people up at the airport, stop at our shop, and then they'd go on to their manufacturing facility and tour. So it's a 5x10. Probably the most notable difference on our machine is that we have a moving table, not a moving gantry. That's, I think, Onsrud and Como and Northwoods, I think, are probably the only people doing that. It's not really better or worse, it's just different. It allows us a little more options as far as being able to put clamps and things. We don't have a pinion track or anything down the side, so we can put clamps as long as you can see those little caution tape on the table. So that's an area we can't put clamps, but pretty much everywhere else. So it gives us a little more versatility, and we don't have any of the safety shields or anything around it. So those were kind of some of the things we were looking for. We were looking for kind of a redneck machine that would let us do what we wanted to do, how we wanted to do it. I don't know. I think the guard around the head is adequate. It's bigger.
How much bigger?
Probably 1.5 times. I mean, we've got about 18,000 feet. At the time, we thought we'd never use it all. Now it's starting to get tight in there. We also have, if you look, we've got some shop-built roller tables. So this was kind of prior to the auto load stuff. We saw those somewhere, and we thought it'd be a good idea. It's been fantastic. So the machine's a 2003. It's still extremely relevant. I mean, we've had one spindle and very few parts on it. So that's my advice for anybody looking at a machine is overbuy. Buy way beyond where you are. Buy for where you're going. But yeah, it's been a fun machine. It's actually our second machine. We had a small point-to-point before this. That was what I learned on, and I learned on DOS. And it was kind of funny. We bought out somebody's lease, and then we were like, we got to find somebody who knows the CNC. Well, we thought they were out there, and I had to become that guy. We didn't have anybody available. We thought everybody was out there, and there's all these CNC guys just in all these shops, and we're like, we just got to find one of those. And I think we've donated more of those to other shops than anything.
All right.
Ready? All right, so just briefly to review geometry and what we use different tooling for. We have our downcut bits, which will be the first slide there. Typically, we would use that for very thin work where we don't want the upcut or compression bit to lift it off the table, or doing shallow pocketing. Then we have an upcut bit where perhaps we're going through a very thick timber, up to 7 inches on our machine, and we want to evacuate those chips out of the board quickly. Then we have our compression bit, which is typically what we use 90% of the time for all of our nested base sheet good cutting. And these come in different configurations. There's a mortising, if you do a lot of rabbiting and stuff, where you have probably 3/32 or a 1/8 inch turnaround on the bit between upcut and downcut, and that allows you to do a shallow pocket without tearing out the grain. There's also chip breaker configurations in these, which work great for plywood. They don't work as well for flake board and MDF. And then there's a ball end mill, which you'll see in some of the videos and pictures, which we'd use for three-dimensional work, relief carvings, doing curved moldings, and the sort. Typically, I mean, advantage of the solid carb bits is they're very sharp. They tend to be available from many different vendors. And then we have our stock braze-on router bits, which are nice for if you're doing, say, a radius profile and you have a profile on that molding. Sometimes stock geometry brazed-on router bits might fit the bill versus you get to do a tool path to create a profile sweep on a curved molding versus taking a ball mill where you actually have to do a 3D surface carving, which can start to take a lot of time. You have to know a little bit more about programming. They're usually less expensive than your solid carbide bits. Disadvantage, usually you're going to have to run your router slower. You're not going to be able to achieve the feed speeds that you can with solid carbide tooling. And then there's also insert tooling. So if there is a particular raised panel that you're making or a profile that you're always cutting on your CNC, sometimes getting a custom insert tool is a great way to go. We had a series of about 100 raised panels that had the bits about 6 inches around that had a rather long, flat bottom before the raise so that they could do an applied molding. And we ended up buying the insert tool and then 2 or 3 sets of the insert tooling, which was great because when it's time to swap it out, you just take 2 screws out, put the new insert in there, and you go.
Is anybody doing like extrusion drawing and cutting with a ball mill right now? Of course Keith is. I don't do that. I mean, I have a few times. If we're doing any level of, I mean, if it's a one-off part, I'll do it. But most of the stuff we do, it's a whole bunch of something. So that picture on the top left is actually a braze-on that we had made to match a molding that we have made. And the nice part is with CAD and a CNC, we cut a lot of our own templates and we send them off to people to have very accurate knives made, and we control the tolerance on it that way. To me, it's even better than sending a lot of the guys CAD drawings because all they're doing is printing out a PDF and, spray mounting it onto something and grinding it. So if I can cut it on the machine that I'm going to be cutting with, it just seems like it holds tolerance better. I think a bit like that might be, I mean, they're $150 to $300 depending on who makes them and what your turnaround is. And you might use them for a job or two, keep some good notes, and use them again when you need to. If you keep good notes, you can come right back to it and touch it off and go. The other one, the yellow one, that's a Woodtech one. I think they're probably here. They're kind of a cheaper importer of a lot of stuff. We buy a ton of little veining bits and things, and we actually modify them and kind of Frankenstein them. We've got a little diamond chainsaw grinder sharpener thing. So if you guys hurt yourselves, it's not my fault. You just got the idea here. But we tweak the bits quite a bit to do different things to them. And I mean, to me, the bits are cheap. The machine time is expensive. I'm sure if you guys are running nested machines and in this economy, you're probably kind of backed up on the CNC. So that's why I don't do the ball mill carvings. We figure our machine rate at about $150 an hour on the machine. So if I'm making a little tiny carving that I can buy from somebody, or, in the case of moldings or basic stuff, I'll just have a bit made. I mean, you can do the big aggregates. If we're doing a ton of it, then we'll do the inserts and have a custom insert ground. The hot thing now is the standard cutter where you can get all kinds of different inserts for it. So, I mean, talk to the tooling people downstairs. They've got some phenomenal ideas, and they may not have it sitting in the catalog. They may It might be something they've done for somebody else, but get a good relationship going with those guys. The last thing with regard to that braze-on, there's a lot of people that sell little like business card size diamond files. You can see that one's got a little bit of pitch on it or a little bit of burn. We'll take something like that, and rather than sending it out and have it sharpened and change the geometry, we'll just lay it on a wet file and just lap it a little bit, and it'll be fine for a while. I mean, a lot of this stuff we're running it out of like big pieces of MDF or Xtera or Mirtex, so it's not like we're worried about tear out and chip so much as you would be in cross grain and hardwoods. So like I said, we kind of just quick and dirty on a lot of stuff, redneck it up. It's just a means to an end for us. I have no idea. We just start slow and just keep cranking it up.
Generally, you're gonna run the braze-ons slower. You're probably gonna be running around 15,000 RPMs, and that also is directly related. That large raised panel insert cutter I was talking about was running at about 7 or 8, because the larger the diameter, the slower you gotta spin it. They will. They will. Recommendations, and then the feed speed for a braze-on is probably 250, 300 inches a minute.
Yeah, and the little tiny one, I don't really care about balancing it. When I start to get bigger ones, then I start to be more conscientious of it. The other thing we do is we get new collets and collet nuts about once a year.
How you balancing it?
I've got a sharpening guy that'll do it. So I guess I got to share that. Yeah, I've got a sharpening guy that's literally around the corner from me too. So if I got to do some big modifications, I can go use his equipment. So that's a pretty sweetheart deal. But yeah, any questions on that part?
How you know it's out of balance?
You'll hear it.
Did you have a question?
You said new collet nuts. I, the collet I understand, but why the nut?
They wear out too. They get elongated. They lose their tension. Some of them are coated, so they tighten and loosen better. So it's just, I don't know, they seem like they get out of balance. I mean, if you're cranking on them all the time, you see how they get a little bit bent and things. If you're spinning it at 18,000 RPMs all the time, it's going to add up to wear on your spindle. Just something we do. I mean, we were just taught that by the tooling people, and it's like, some people change your oil at 5,000 miles, some do it at 25,000.
Do you buy new, or do you have them balanced?
Just buy new ones. They're not that expensive. We work it into our pricing. And I mean, if we're doing this kind of stuff and some of the pictures you'll see, we just figure that into the pricing. There's kind of a tooling charge that goes into it. Don't be afraid to charge people what it really costs. I think we're afraid to do that a lot of times, and all it does is it ends up driving our prices down, and then other people come and hear about what you did and how much it was. I mean, when you guys get a great deal from somebody, you tell others about it, right? Builders and contractors and architects do the same thing. So if they all come running because you have low prices, and you kind of get stuck in that.
Yep.
What are your thoughts on the ball bearing nuts?
I don't have any. I think they're cool. I like the Hydrolock ones and all the different stuff. We just basically have what we started with, so we just keep replacing that.
That's kind of what we have. We started with ball bearing.
Yeah, I think they're slick. I've never been, I don't know, take a lot of chances, but some things I don't mess with.
What are those? I don't even know what that is.
It's just like it snaps together, basically. It's just faster.
Ball bearings inside the top of the nut. Again, I don't know enough about it.
Yeah.
And it's,
That's not what we bought all of ours. That's what it was.
I'm actually asking this because I want to know, which is why I'm here, not, I'd rather be out there,
If you go down to Technic's booth, they'll have them.
but you didn't tell me to get that, so I don't have it.
You didn't need it.
I mean, that's honestly the truth. When I bought my machine, I leaned on these guys really heavily.
if you just click on the picture there, it'll, on the,
Oh,
the video should come up on it.
it's moving.
Okay. So, workpiece holding, which as you get into using your CNC probably for more unique operations, there are a number of ways. I mean, the most common way you're gonna hold parts on your nested base machine is with your vacuum pump, pulling a vacuum through your MDF spoil board. Other ways are, in this particular operation, I'm doing a mirror image, a flip side machining operation where I'm making table stretchers with tenons on the end. They're also an angled tenon. So I'm gonna machine one side of that tenon about halfway through, And then what I've got here is a secondary spoil board to lock that piece in, and I created that pocket in that piece of plywood with my CAM software so that I knew when I drew the part there that I was gonna get precisely the flip side I want. So at that point, I'll actually screw that piece of that secondary spoil board down so that when I'm moving something, I don't, accidentally shift it. And then we'll machine one side halfway through, flip to the other side in that pocket, and then machine the other side. And the nice thing is that you're creating all your geometry to do this flip side of machining in that pocket that you've also created in your CAD/CAM software and cut with your machine. So you just have that accuracy there. If I were to make a run of these, this is a table that I designed when I was in school, and I decided to basically digitize the design for a presentation I was doing. But say I want to do 10 or 12 of these, you could take your whole table and make a series of these pockets all over the table, and all of a sudden you're now cutting 10 sets of stretchers, 10 sets of tabletops or whatever it is that you're making. What's that?
Get a little closer to
Oh.
the mic.
Sorry. Yeah, if anybody can't hear me, I have a,
Well, they can't hear you in the back.
sorry. Just raise your hand and say, speak up.
Is anybody using gaskets on their table? I'd highly recommend it. We run a gasket around the grid table that's just a little bit proud. Even though we slide the spoil boards off, they kind of get a glaze on them. First few times they'll catch and tear out and you'll swear and curse my name. But it seriously increases your vacuum and your workpiece holding. And then All-Stars downstairs too, they are kind of the people here that do it. They sell a gasket tape that's self-adhesive, and they'll have little demos. You can whip it around, but we've got rolls upon rolls of that. All-Star adhesives. I can't remember. They're either in Rhode Island or California. I think they may have moved. They're good guys, and if you tell them which machine you have, you can trust them. They'll give you good advice on, they memorize every machine and which gasket fits it best and which one works. But it's phenomenal stuff, and when you use it on the spoil board, if you've ever hit the vacuum button and it kind of is a taco shell and it doesn't go down, this will help it grab.
So I've also heard on this that depending on your vacuum, it can also cause some cupping. So if you don't, Matt's got a 30
Yeah.
horsepower vacuum.
And my table's aluminum too. I don't have a phenolic or wood table on mine.
But I have heard from some manufacturers that you can cause some issues with that if you don't have enough vacuum to actually pull it all the way down. So talk to those guys and they'll tell you whether you do or don't probably. So that is something to think about as well.
And as we go through this, a big part of this, again, is how are you holding the stock on the table? There's a couple composite nail gun manufacturers. Raptor is one of them, where it shoots composite nail into a board. Sometimes when we're doing a curve molding, especially if it's poplar and I'm not worried about it, we'll actually shoot nails right through the geometry, and they machine without any fear of chipping or sending sparks up. And if you hit a black screw with a solid carbide bit, it's shrapnel. I mean, they impressively explode. So you have to be careful. You have to know where your fixturing is. If it's clamps, if it's metal nails, if you're using sheetrock or just cabinet assembly screws, you just have to really know where they are. And sometimes it's usually going to be on your outline pass when you might come close to those. So a lot of times what I'll do is I'll just put a Z-axis lock on it, and I'll just run the outside perimeter and just watch the bit and make sure I'm not passing anywhere near my fixturing fasteners.
We've got a pretty simple L-shaped piece we made out of a piece of 1/2-inch plywood, 12 inches, 12 inches. So when we're doing little pieces, parts, something to just a door, we'll stick that on, reset XY0 to 1212. We can stick that on the corner. It gets it more in the middle of the table into the vacuum zone. We can stick something else up against it. Kind of helps keep it from moving around. It was pretty simple, but I'm sure I got the idea from one of these guys. But
We actually use our part location pins as clamps too. I don't know if it works for everybody. Ours are plastic and they're circular, so we drilled in and threaded the top, and we just have different sized discs that we put on there. And because our table moves and not the gantry, we can get pretty big, but we'll actually run a strap across sometimes, and then we'll cut and hop up over it. We'll just put that in our programming.
Any photos of that?
No.
Not in here, anyway.
Can you send them one?
Yeah, I mean, I can send you one. Like I said, we have a Como. They're pretty much the same machine. If you go look at their part location pins on them, you'll see what I'm talking about. It's just a big plastic pin that pops up and down. But I mean, you can buy those. I don't know who makes them, but you can buy extra part location pins too and put them all around the bed. It's not a bad idea. We also have go ahead. I was just going to say, we have a peel and stick tape measures all around the bed of our machine, so we can kind of quickly locate stuff on there. So I'm not measuring the table ever. It's just it's a small thing, but it saves a ton of time throughout the year. And that way too, if there's an issue on a part, I can look at it and tell where it is too. Go ahead.
You mentioned gasketing and talking about cutting a pocket. Have you ever pocketed for a gasket in your spoil board and then to fit your part?
Yeah, I've done that. I don't typically do it into the spoil board. I'll put a piece of melamine on top so it blocks off. Like, we keep our cover sheets in a pile and we'll save them for stuff like that. So basically, like, you see that pocket there? We would do that so the melamine's going to block off all the vacuum elsewhere. That's a big deal, is blocking off your vacuum. But I'll give you guys some other advice. Don't ever use poly or plastic or anything like that, or like peel coat type stuff. I've seen people put like that stair protection or carpet protection tape down. Don't do that. Don't put tape on your machine. If that gets sucked up, we had one of our CMA members sucked up a sheet of plastic and basically welded his spindle in place with hot plastic, and then it cooled off and he had to chisel it off. And I mean, it was just a nightmare. Yeah, it's not cool. So I've seen more than one person do it where they just use like construction poly to block off air. Don't do it.
Along that line, if you're cutting plastic that has a film coat on it, you want to make sure you take the film coat off before you cut it.
Or use compression bits. But you can you can spray WD-40. We've got an edge bander that works really well with peel coat stuff, and there's some anti-static stuff. You can just buy that and put it in a spray bottle and put it on there. It'll make a huge difference.
I use stretch wrap to go around pieces when the spoil board gets a little, pocketed and stuff. And sometimes the compression bit will grab it, but
You're playing with fire.
no, I don't know, maybe I'm running at a lower speed or something. I mean, it'll wrap around. Sometimes it'll make a funny noise, but I've not had it melting. Maybe it's a difference in too much thinner kind of wrap. And also, I don't do a full
Yeah, I mean, if
cut to a 3-inch strip or something like that.
you're not getting enough of it at once, but you get a big ball of plastic in there, you're going to know it. And there's one other thing I was going to say about that too.
Where are you spraying anti-static? Where you just spraying it on the panel?
Just spray it right on stuff with a peel coat sometimes if we're doing specialty work, and if you can tell if it's starting to bubble or pop up or it's peeling. But sometimes I want to keep that peel coat on if it's something that's going to be, if it's a top that's going out to a job site or something. We all know what happens to workbenches on job sites. So,
And
Flat places become
yeah,
more.
horizontal surfaces get destroyed.
I've generally found that the adhesive on the peel coats, like on some of the decorative Chinook panels or some of your
Those
high
are
gloss
horrible.
panel. What's that?
Chinook peel coat,
Right,
you
'cause
have
it's
to take that off.
Yeah,
in
I
my
was-
opinion.
Yes, I mean, you'll be able to tell looking at it. If you can sit there and flip it with your fingers and easily pull it up, you might consider pulling it off.
Well, and it also half the time that it's bundled up on one side or the other, so you can't even get the thing to sit flat. But
So basically, you have dead stack material with peel coat on there that sometimes sits for months, and it's in a container out in the sun and eventually gets to you, and it's pretty much welded on there. The other thing too is we use a lot of anti-static spray on acrylics and things when we are cutting plastic. So if I do pull that stuff off, I know the guys down at Stylite, they sell some pretty cool anti-static sprays. You can get it off of Amazon. Pretty much any plastic machining shop will have it. But it's pretty funny when you cut that stuff and you just get balls of material on there because of the static. You can see the electric charge moving around on there, especially in the wintertime.
what's that?
What?
Winter,
It's winter. I know, Mr. I don't own pants.
right?
So, in this example, this lower left-hand side here is a corbel that actually Osborne asked me to make because they couldn't get delivery on a Rift-Son oak corbel for about 6 weeks from their supplier, and they needed 2 of these. This is another case where I used a jig. In this, it's just a simple L-shaped piece that you see screwed down to my MDF spoil board so that I could take that board, slide it into the corner, and basically then I did what Matt does, is I took pieces of melamine and I blocked off the vacuum around it so it wasn't going to move. And in this particular corbel, this is where you're going to start to consider what you're going to use for your tooling geometry. There's these reliefed pockets in the center of the part and along that serpentine edge. That's where I'd go and take a downcut bit. That's a perfect example of where and why you'd want to use a downcut. It's going to cut very clean. It's not a terribly deep pocket, so you don't have to worry about heating your tool up. And then the little spheres on the end, if you were to do a bunch of these, maybe you'd get a custom bit made so you could just do a single tool path around the circle. But with those, I just did a basically solid surface machining operation. It was a little partial sphere, and then I took a ball mill, probably a 1/4 inch or 1/8 inch ball mill, and basically stepped over and stepped down to create that geometry, that dome. And then I would take a straight cutter bit, probably a down cut again, and go around the outer diameter of that dome so that I have that real crisp edge, so you don't end up with the cusp or the radius of your bit showing up in the geometry. And
Does
then
anybody do stuff like this?
When I get odd stuff like this and I'm not able to buy or use a profile bit to do it, I actually buy a lot of just Chinese carbide bits. And if I need just like a weird radius or whatever, MSC Tool sells them, Enco, Zorro, Amazon. And sometimes there's a crazy lead time, but we get a lot of little small detail bits and a lot of stuff. If we're just doing a small run, I'm not going to spend a lot of money on bits. Or if it's kind of an experiment to see if it works, we'll play with that first. And we just run it at a little lower feed speed. The rake angle isn't quite as aggressive. It's usually get a bit that's for aluminum and it'll machine wood just fine.
And this again is going to be a flip-sided operation. I think it was about 3.5 inches thick. And you can see on the face of it, if you were looking at the corbel straight on, face on, there's a reed that actually goes down along that serpentine S-curve. Again, we used a ball mill bit and actually did a step down to create half a reed. Then we took our part, flipped it over in the nest, and you're gonna flip the geometry on in your CAD CAM program too to create the 3D milling operations.
How did you hold it down?
Basically, I have Matt asked how we held it in place, and it was with the vacuum table underneath, and then we had that basically an L-shaped cutout on the X and Y axes, and then we took melamine and put it all around the outside perimeter of the part, and we machined right down just beyond halfway through the part. So the block, I don't have the laser, but the block that's out
Right there.
right out in front of it, we kept that intact so that we could take our jam boards or the pieces that are shutting off or blocking off your spoil boards so you're not bleeding off vacuum. So we still had it holding tight. And that last little cut that's going through, I mean, it's such a fine cut, you don't have to worry about the part jumping. If you were doing it with a big upcut bit and we were going straight through, that's when you have to be more concerned about the part, because they're very aggressive, the upcut bits, jumping up out of the part. So again, if you are doing a straight final cut, you might consider switching the geometry of your bit for that final pass where you actually cut through the part, so it's pushing down on it rather than pulling up.
When we do a part like that, we'll often leave tabs on it, like on the square sides, on both ends, and then we just put, we drill 1/4 inch or 8 millimeter dowel holes in our spoil board most of the way through, and it's kind of a registration point. And we'll just keep flipping and using those tabs on the outsides of it, and then when it's done, we'll just knock them off with a saw or a sander. And usually it's on the back part that goes on the wall. A lot of different ways to do that kind of stuff too. We'll screw stuff down. We'll buy nylon screws sometimes, and we'll put T-nuts into the spoil board to hold stuff if we're doing stuff that really needs hold down. And we try to determine, is it hold down or is it linear shear that we're worried about? Another thing that works sometimes, depends on the wood, we'll use double-sided carpet tape. We'll put that on. If it holds really well, then if it holds too well, then we'll spray it with denatured alcohol to get it to let loose. The caution with that or thinner or anything is obviously the flash point first and foremost. With static electricity, you got to be a little careful. Secondly, if you have any sort of plastic or anything around that, don't do it. It'll craze it, it'll ruin it, and it always is expensive and hard to replace parts that you blast with thinner or alcohol.
Is everybody sealing the edges of their spoil boards, either with paint or whatever? Pretty much?
You should.
I do it most of the time, but then of course there's always the, well, I'm in a hurry and we gotta swap it, so.
Little pro tip is go to Home Depot and buy their $5 Oops paint. Doesn't matter what color it is, and a gallon will last you for years. And that's the first thing we do when spoil boards come in. They stay on the forklift, and guy walks around, and we buy those little 3-inch wide rollers, a couple rolls around, and you can see the spot on the floor where we always paint spoil boards.
What's that?
What is, do you read your digital readout on the back here? If you have it painted or not painted?
I don't know, it's about this much on the dial. I just know it works. I know when somebody hasn't done it and somebody's coming up to get a lot more parts because we're making defective boomerangs. They fly off, but they don't come back.
Yeah, and don't take a quick way out and think that, well, duct tape is waterproof, so I'll go around the exterior with duct tape, because it will get sucked up into it, especially if you're running a spoil board operation and servicing.
We've edge banded them too. That works, but it's such a pain with a 5x10 sheet. It's a lot of work, and we've actually broken spoil boards because they fall off the edge bander. And it's just, the other thing is the edge banding can just fall off sometimes, or it gets sucked off or cut off.
It makes a difference for us, I know. I mean, with the 16 horse, we use a melamine part for drawers and backs. We use a Plum Legra box. Sometimes those backs are small and they're really, really slick. And if we don't paint the outside of the board, we lose a lot of those. And we still lose them from time to time, but that doesn't happen as much when we have.
And
I don't have a gauge on mine, so I couldn't answer that.
talk with your spoil board supplier too. Let them know you're using it as a spoil board. I mean, if you're just ordering sheets of MDF, they're going to send you sheets of MDF. They don't care.
Do you have a brand that you like?
We've had good, what's that?
No, don't use Medics. You can't pull a vacuum through it.
No. I think Plum Creek is what we've been using, but the thing is with suppliers, they make changes and they don't tell you. You just get stuff, so.
They can't give you the density of it. It's a range.
It is.
It's a range from 30 to 50. It's darts.
And two, find out what the actual material is in the spoil board and keep good notes on it. I mean, we have a binder with our CNC, so we know all the weird little products, every little lube, every part we've ever gotten. We keep it in a binder so we can reference it quickly.
Tried the lightweight stuff ever?
Yeah, by mistake.
Yeah.
Didn't work. Too much vacuum. It was like a sponge. Hardwood MDF too. We've had really poor success with that. It's darker. It's not as fine, not as refined. So it seems counterintuitive, but like the finer and the more dense it is, the better it works.
Yeah.
Ask your supplier what's everybody else using.
Yeah, I mean you don't have to work that hard. Just ask somebody.
What about the thickness? I know, obviously, as it gets thinner, you're going to lose vacuum. But is there a point of no return, like we should be throwing a 1-inch board on there? You know what I mean? Is there like a bell curve of, hey, you're getting too thick, that now you're losing vacuum because you're too thick?
You saw how we moved the spoil boards off. We don't want it any heavier than it is. And we just do 3/4 because that's what we've always done. I mean, it's definitely worth exploring. There's a lot of guys too that use a thinner spoil board and then they use a 1/4-inch sheet on top as their sacrificial piece. So it's a 2-part deal if they're sliding pieces on and off.
So what they're doing is they've got 2 1/4-inch pieces. They can pull all their parts off at one time, throw another piece of 1/4-inch with a sheet on top of it, run that part.
Right.
So they can,
Now I got you.
the machine's running while they're labeling parts or whatever.
We tried it. We just beat up more corners, so it didn't save us anything. And then it was so thin on our roller tables, we had to move the tables closer. The surface wasn't big enough, so they were bowing and parts fell off.
The slide on the right there, oh, go ahead.
I was gonna say, along that line, I know a shop that does what you're saying. They have like a 1/2-inch spoil board on the bottom, and then puts a 3/4 on top. He had to do extensions on his locator pins, but that way he can run his 3/4 spoil board all the way down to a 1/4-inch thick before he changes it.
Yeah, I mean, it just comes down to what machine, what pump you have, what your suppliers have available. You got to just play around. I mean, I can tell you exactly what we do, but it might not work in your shop.
And the slide on the right there, the picture on the right, is actually a good example of tabbing parts. We had to make several hundred of these, and you can see running down the tool path there, little 3D bridges. And most all of your CAD CAM programs will have an option that's usually just a click of a button, and you say add tabs, and you can space them out. And you know, if there's certain areas where you know you want to hold tighter, you can put more tabs right in that area just with a mouse click. So
What software do you use?
for stuff like this, the Corbel actually was done in Bobcat Cam, which is a full-on, you know, you have to understand tooling and feed speeds and tool strategy. There's no, it's a workhorse. You know, there's no automation really to your programming and your tool pathing. And the one on the right there was done in VCarve Pro, which is very intuitive and very simple. But again, you have to know what tool you want to use. It's not going to auto-select like AlphaCam and Cabinet Vision. Basically, you have a library of tools, and most of the tool selection is automated. I mean, there are parameters that you put in the beginning, but then it's great how intuitive it is.
We use Router Sim really only for two reasons. One, we have a lot of people that are really, really good at CAD. Well, three reasons, I guess. Number two is that CAD's kind of the standard language, so we get a lot of stuff from architects, and we just put it right in and basically give it a tool path. And then the other reason was it just came with our machine. So it was just, we knew CAD, it seemed logical, it came with the machine, and we had support with it for a while when we got it until we were up and running. What are you using for your custom stuff?
We use Aspire, Vectrix Aspire. Same reason as them. It came with the machine.
And that's a great program. Anybody who wants to get into 3D machining, it's easy, it's intuitive, doesn't crash. I mean, it's a solid program.
Yeah, it was pretty easy for me to pick up. I'm not a CAD guy. I've never played with it at all, but I knew SketchUp, and it's all kind of the same, I think. But yeah, it was super easy to pick up, I thought. I still screw things up, but you know. Wouldn't be any fun if I got it right all the time.
Oh, go back up one. There you go. You can hit that screen. So in this slide, we're just looking at different products. This was
Microphone.
oh, sorry. This was a job for a lighthouse, and we had to make a couple hundred balusters. It was down in Cape May County where there's a lot of Victorian homes. And basically, in VCarve Pro, I had the geometry or the silhouette of one of these balusters, and I took 10-inch wide, I don't remember what they were, 10-inch wide boards that were 10 feet long, and I laid 6 of them across the 60-inch width of my CNC bed.
So this is solid wood?
Yep, this is solid wood. And then just copied and pasted the maximum number of parts that I could get into that nest. So we were cutting out, 25 or 30 of these balusters at a time. The vacuum was absolutely fine to hold the cedar down, and it made great use of the vacuum and fixturing, and also being able to mass produce it. Some of the other things you can make are louvers and vents, which we'll look at down the road. Interior and exterior architectural elements. I mean, if you're doing residential, commercial work, there's always those big corbels on houses, or, curved moldings. Your CNC, your 3-axis nested-based CNC is great for doing that work. Framing components, we do our beaded face frame haunching, which we'll see down a few slides down. Matt?
We don't pursue a lot of this stuff, but sometimes it finds us, and we use like the big architectural elements and things more as a way to get in with, kind of come in the back door with some builders and architects and things. They see that and ask who did it, and they come to us, and then usually they come and see the shop, and we end up doing more work for them. So it is a good sales tool, but I don't think you get rich on some of the stuff. Some of it you can do quite well on. Some of it's just really competitive, but louvers, vented doors, a lot of different things like that. I mean, some of the stuff actually helped keep us alive during the recession. We got some orders for some, $3-4 million homes that needed all of these elements, and you do one thing, and they're like, the framer would come to you and say, can you do this for me? Can you do that? And we'll get into some of those pictures. And some of it, too, is just a time savings when you get these houses that are, 15, 20,000 square feet. they only have their really good framing crew, and there might be 6, 8 guys, and they just can't keep up. So all of a sudden, we're literally making the framing components for rooms and dropping them off as fast as we can go.
Have you guys ever cut that white exterior poly material around? Is that
What's the question?
The PVC, yeah, cuts great.
Yeah.
it chips off? Does it melt?
You got to pay attention to your feed speeds and all that, and your tooling. But you can make a big mess with it too.
Yeah, it's spinning your tool too fast and moving too slow. I mean, generally, you want to be making chips and shavings. You don't want to be making fine sawdust because it'll start welding itself to the bit, and it welds itself to the bit.
We absolutely will not cut anything with silica in our shop or fiberglass. I've done fiberglass. I don't like it. I think it's pretty toxic, and I don't know. I mean, our dust collection's good, but I just don't want to breathe it and wear it. Silica, I don't want it. I can't risk it. I don't need it in my spindle. So if somebody's going to pay me a couple $1,000s, I'm going to need about a $20,000 deposit on the spindle. And we just don't do it. I don't want it in the air in our place. I don't want to open the door to silica stuff if anything ever becomes an issue.
What would be silica or based?
There's some exterior kind of cement board type stuff that we've had people approach us to do curves and arches and all these little elements, or to cut kerfs and things so they can bend it. So we don't do it.
Yes.
Cuts like butter. It cuts, the old flute, half-inch old flute. It makes just.
The decking stuff?
The 4x8 sheets.
Oh, okay. Yeah, I've done some of the King,
Yeah.
yeah, yeah.
And it's a huge profit center. People, builders, and people.
Need young, strong guys to move that stuff.
Yeah, the density on that stuff is insane.
What is the cellular PVC? Are you talking about the cellular PVC? Yeah. It's kind of like the King Starboard is very good.
Yeah.
We have a shop in town by us too that's kind of a specialty PVC shop. They have large, long tanks full of oil that are heated, and they'll dunk it in there and they'll twist it, and it looks like wrought iron, but it's PVC. And I mean, they'll do all these shapes and bends and compound angles. It's pretty wild stuff.
One of the things that we do in commercial work is we've got curves and serpentine walls where putting trim or paneling on is we'll offer to the framers, because we all know how good drywall framers are. We'll offer to the framers to make a template or a subplate or just make his wall plates for him. And now I'm ahead of the curve on making my paneling or anything of that nature, because I know he's gotten my cut parts.
Yep, our products fit our walls a lot better than anybody else's walls.
The suspended clouds are now really popular commercially this some year. We've done that where, drywall got hired to create the cloud. The cloud was so bizarre in size and shape that, it was impossible to create. We just made the ends and we filled in the blanks.
It's funny that it's actually happening now. We were on a job site in like 2009, and the new framer looked at the architect's cloud call out, and he put it up there. Everybody walked in the morning. This guy stayed late to work on it, and they're like, he did a really good job, but really? It was epic.
Hey, to back up to tool holders and whatnot, is anybody using those? I've seen them before. They create vacuum venturi type thing to hold the tool. They work. Yeah. Because that's the thing I would personally be interested in getting better vacuum on. Yeah. Huh.
You got it dialed in
Yeah.
really well, but we have a dedicated nested router with that 480.
Yeah, whatever they call them. Yeah. Interesting.
Yeah, they work great. Some of them have a large enough opening in them that if you have a small little piece, it'll pick that piece up.
Oh.
And then it'll spin it on the board and burn a big circle when you're in.
Oh.
It's like a big hole saw.
So you have to kind of watch.
Yeah, just somebody came through with one, and I was like, I don't know. It's a lot of money.
They work great. You just have to, in your programming, you want to avoid small little pieces.
Okay.
Next.
Yes.
Next.
We have 8 live foot machining centers, and we started with
Yeah,
and it keeps the shop clean. It's better for my employees as far as
yeah.
breathing in dust.
Well, any dust removal too is gonna cool it.
I think in the long run, it's well worth it.
Is there any issue with, I always wondered about just the amount of dust of getting it up, worry about getting it up into your spindle under a little more force than it would normally be happening? Or is it really going right directly to your dust stream?
We've got hand routers, they're older spindles, but we have, I think 225 horsepower of vacuum.
Wow.
Keeping the shop clean. So all dust gets pulled out of the shop and withdrawn.
Okay.
They're not too much pressure, the key is just getting it out of the day, getting it out of there. Once it's out, then it's,
Sound impact? Are they noisy or?
no,
No?
See, what I have a particular problem with is some drawer bottoms. We have to cut a little, like an 1.5 inch wide dado, and we use a moisture grade MDF for that part, and that green dust is everywhere after we cut them. That, because we're only going down like 1/4 inch, and that bit is, so the shroud is now 4 inches up off the table, and just wondered if it would.
and the limitation is to it is it does limit where the depth that you can cut with the cutter.
Yeah, I mean, honestly, for one tool, I would be
Yeah, I mean,
particularly pleased if it worked.
if we're cutting MDF doors, when we're hogging out.
Yeah,
We have one on that, and we have one on our compression bit,
yeah,
so that's what we're using.
all right,
They work great.
yeah, awesome.
You can click on that one too.
So, this is a curved arch. Again, if I was doing more than one of these, I would probably go out and buy tooling to match the profiles. Again, the advantage of that is a simple swept tool path is probably a matter of a few seconds versus ball milling an entire profile out, it could be an hour or two. So for one, if you don't want to go out and spend the money on the tooling, you can ball mill just about any profile in any kind of an S-curve, circle, whatever you want. As far as fixturing and, fixturing and holding this, I just put the board down and then I put boards around it to cut off the vacuum. And in this case, I used, it's either screwed down or nailed down with the composite screws, so it's not going to shift on me. And then it was a series of ball mill bits, probably starting off with a 3/8 ball mill bit and working down to an 1/8 inch. And then there would be a need to go into any of the areas where you have that, again, the little OG curve and it steps down to a flat field. You'd want to come in there again with your straight cutter, down cut bit, so you have that real crisp transition in your geometry. Matt, you do any of this work?
A little bit. We usually just have a bit made so we can go fast.
Right.
Usually it's just while I'm waiting for the bit to be made, I can get material in, get the arches, glued up, whatever I need to do.
And it can be a combination of bits. When you see the profile, there's a bead running on the front edge. So instead of taking a ball mill and stepping over a couple thousandths and stepping down a couple thousandths, if it's 1/4 inch bead running on the front of it, you could take a simple stock brazed on bead cutter or V-bead cutter and run that front edge and then run the back side of it in 2 tool paths and then come in maybe with a 3/32 or an 1/8 inch flat bit to create that valley transition. It depends how tight and what the resolution of your geometry is. The tighter you keep that step over, which is when you're doing ball milling, if you were to step over 50% of a 3/8 bit, you'd have this scalloping in your board. So the tighter you make that, in your final pass, maybe in your rough cut, you do take a big step over. If you're using a 1/2 inch bit, maybe you step over an 1/8 of an inch or a 3/16 of an inch. And then you come back and take the last 2 or 3 thousandths off with your 1/8 inch or 1/16 inch ball mill bit. That way you can run it a little faster. You're not going to break it, but you're probably starting to step over 10 thousandths of an inch at a time if you really want to make a tight resolution that you're not going to have to sit there and sand all day.
And for me, I'll do this stuff if someone will pay me $600-800 a piece for custom pieces, because that's really what it costs. When you engineer it, you run it, the first piece doesn't always work out, you get a chip or whatever, and then you're right back to zero, and now you're losing money. So I think it is hard to get people to pay what it really costs to do this. And so that's why I like the approach of just buying a tool for it if I can, just because it's like, well, I know what my costs are a little better. You know, I've got a drawing of a profile, I send it off, I get a quote on a tool. I know it's going to take a minute and a half to machine and it's done, and then the CNC's back open again. I don't like putting lots of hours on the machine and having runs that go on and on and on when we're waiting for other stuff. Or if I have an issue or a tool breaks, then it's like, all right, now I got to touch off. That gets a little hairy.
Can you cover that front beaded profile? What tooling are you spinning in a 3-axis machine to get that? If you do that in one pass and then the rest of the profile with a custom tool?
Right, so I mean, there's two ways of doing that. You can do a ball mill, basically a surface machining. Right, the step over.
Need
Or
an
you could take,
aggregate.
if the first or second slide on in your presentation there, the braised on bits, there was a little
We'll get to some of that.
quarter round.
Yeah, the next.
There's a little quarter round. There you go. There's a little quarter round V-shaped or comes right to a point bit. So you could do a tool path down the outside of that bead, and then you could do a tool path on the inside of that bead. And again, Matt had that bit in the front there that was very similar to the backband profile on this. You might be able to go out and buy some stock tooling and come very close to what the designer had for the profile.
So 2 passes to get the bead, you'll be doing the inside face and the outside.
Correct.
Yeah, a lot of times I'll use like a 16th or an 1/8 inch or 3/32, just a flat metalworking mill bit to get that bottom flat in the bead so it doesn't look kind of bubbly. And then the other thing I'll do too is I'll take that bead and I'll jump it over just a little bit so it's, I don't know, it's just something we do, I guess. So there's a little more space so it looks like true beadboard.
Okay, in this
Yeah.
in this photo, we actually had a run. It was this Art Deco kitchen and living room. Basically, we had these waterfalling columns, and we needed our crown molding to follow that sort of double curve waterfall. So we were able to have a head made for the CNC, which is basically aircraft aluminum. Schmidt made this particular head, and we were able to use our shaper tooling in this head. It's, if you really think about physics, I would stand behind a cement wall when I would run it. Because there's nothing guarding it. I mean, you have some plastic flaps on it. You really have to understand your tool pass strategies. This crown here you're looking at is a 2-piece crown. That was not done in one pass. That's how it was kept so clean. And it was 2 different knife profiles, and it's stacked one on top of the other. So it's actually 2 pieces for each one of those curved assemblies in that crown molding. And you have to enter the piece creating sort of spring passes, and you're basically sort of shaving off an 1/8 inch at a time. You don't come around and just slam into it with that shaper head and take the full cut the way you would on a shaper or a molder. So you really have to start to have an understanding of physics and what can go wrong. We had, again, a secondary spoil board screwed down to our spoil board, and then before we screwed it down, we had traced the geometry of our blocks that we were going to machine this molding out of, put a couple holes in it, and put screws in from the underside, because with that big head on there, you don't want anything breaking loose. I mean, you want to know that you're holding it, and you have to know that your tool paths are just these nice shaving cuts. It's not a plow it out at once.
So I wanted to touch on that bottom right picture is cut with that bottom left bit. So we're actually cutting a lot of basically curved moldings. Not only, it's just out of a thicker MDF, and then we do the profile cut, and then we just go around with a 1/4 inch bit. We cut actually do the cutout, the miter, everything. So these things come off, they get a quick sand, and basically staple them on. They're paint grade. I'll do the same thing though out of solid wood. I'll just glue up big panels of solid wood sometimes, and I don't worry so much about the material. Labor's far more expensive. So if I can glue up some big blanks and get all my geometry, all my cuts, and everything goes together absolutely perfect, like a puzzle, it's worth it to me. I'll throw some wood in the trash if that's what it takes. We do that actually, and we'll get to this later, but we do the same thing for, well, we used to, before we had more machinery, for like haunched miter joints, like bead joints. we would actually cut the entire thing out, every bit of geometry out of a big board. And the fact is, you're taking a big board on your saw and you're ripping it and cross-cutting it and throwing it away anyway. What's the difference if you throw it on your CNC and cut it out in its entirety with the haunch joints on it? But we'll get to that. We have some different ways we do those.
Any questions there?
The one in the middle there, what's that?
What was the spindle speed on that big shape?
I think I was probably around 8,000 RPMs. So, yeah,
Run it the same as you would on a molder,
right.
6,000.
Yeah, and that shaper head, just because of the way it's designed and the fact that you are taking these shaving cuts, you know, I said, oh great, I have a new molder head, but actually in talking to Schmidt, it's like you don't want to put one of these aluminum heads on your shaper. You know, you don't want to put your steel head on your spindle either.
What is that?
Balance, weight, mass. A lot of times, I think I'm 8 kilograms on my spindle weight. You have to be careful about what your spindle can handle for weight of tooling. You're getting some of these big tools, or an aggregate's also bolted on, but some of these big tools, you can start to get 4 or 5 pounds hanging off of there. And if you think again about it spinning, it's a lot for that
pick it
spindle
up.
to hold on to.
Keep it moving.
Oh, we're running behind?
We're a third of the way in and halfway through.
Okay. Go ahead, Matt.
Okay, so we do sometimes cut some parts more or less just because we want some of the geometry for a library and just the fact that it's repeatable. So if something gets downstream, we can quickly remake it. Stuff always happens. You make a mistake or something gets damaged on delivery. So there are some things we could probably do conventionally faster as a one-off, but as we've disciplined ourselves and done more of the weird stuff on there, we've just gotten to a point where we're faster. We also have a whole wall of jigs and spoil board accessories and things, all the little fixtures. We hang on to them for quite a while after the job's installed, not just after the countertops are on. So for us, it's a lot about repeatability. And we have a lot of people who see our work on one job and they say they want it on another one. So we just open the file and modify it a little bit and reuse it. So this was something we got into, I think it was like 2009. Somebody came to us and wanted us to do these corbels, and the ones on the top were actually the one that they came to us with because their bandsaw guy couldn't do it apparently. So we just took a bunch of extira and basically cut out puzzle pieces. So the outsides are whole, the insides are just puzzle pieces because it doesn't really matter. And then there's a pocket in the back where they go on like a big French cleat. So it's just simple stuff, but we just break it down into layers basically. And then we just had dowels that ran through them for alignment. So cut the part and we just literally had 1/4-inch dowels that were 8 or 10 inches long and just kept stacking. And every run that we made on the CNC, we carved a number into the part so we knew what it was, except the outsides, and they were obvious what they were. So it was, I mean, we had mountains of parts and pieces. If you look in the very bottom right of that cart, you can see that's a run of corbel, basically insides, the guts for the little ones. But it was weird. They came to us with one, and all of a sudden it was just, it kept us busy for months.
And are these corbels and brackets you have, are they one-piece assemblies as far as the outside geometry and then the brace geometry, or is it 2 different pieces?
No, it's
assembled?
all one piece.
One
It just
piece.
looks like 2. There's a little quirk in there that we cut with a small bit.
But, sorry, those are all just 3/4-inch layers stacked up.
1-inch extira. Yeah, you can get it. And the other thing too with Extira and Mirtec, which are basically exterior water resistant MDF, don't ever say waterproof anything. That'll land you in some hot water. You can buy, I think 16-foot, like nominal size, like siding basically. So we've done, I don't have any pictures of it. We've done a lot of stuff where we have NDAs, we can't show customers work, but we've done some big exterior pergolas and just some ridiculous stuff with that, where having those long lengths, we literally just put the end on the CNC and cut an end on it, and that's it. And then the rest is just, you know, it's like 2x10 basically.
You want to do the bed first?
Sure. We don't really do furniture. We try to avoid it at all costs. We're a cabinet shop. That's where our money's at. But for the right price and the right job, one of the caveats of doing this job is we had to do a pair of these bunk beds that were like 13 or 14 feet tall with 3 bunks on them. And we worked so hard to make these things out of rustic alder. They couldn't have putty, couldn't have, any exposed fasteners, no way of, it had to just look like furniture. And the lady walked in the room and you can see it's floor to ceiling wood in this whole house. There's about 3 square feet of drywall. And she walked in and she's like, it looks too much like the walls. We should paint it. And so, but she paid for furniture grade stuff. And I was like, we could have used Bondo and whatever we wanted on it. It wouldn't have mattered. But I mean, she's also the kind of person that'll pay someone to come in and strip it down and refinish it too. So, but yeah, we landed a multi-6-figure job as a result of just the ability to do these. So we just broke it down into individual parts and pieces. The architect actually did 90% of the work. His drawings were so detailed. Has anybody ever played with an architect's CAD drawings? I got the look. He's like, yeah. Yeah, I don't know. For some people who kind of have some pomp and all of that, their drawings suck. The lines don't connect. There's lines on top of lines on top of lines. Yeah, I don't know. I'm going to go be an AutoCAD professor so I can just like snap people in the hand and be like, clean that crap up. And the problem is, to everybody on paper, it looks beautiful, but when you're trying to actually use the drawing for programming, it's horrendous.
I know around here,
Well-
most of the architects are using their interns to produce that stuff, and all they care about is what it looks like on paper.
In this case, we got lucky. We got the guy who was basically an amateur furniture builder, and he was good. He was just really sloppy with his lines.
And we've actually sent stuff back. So, well, we're going to supply you the drawing. We've gotten stuff, and I've basically talked to the person in charge of jobs and said, the drawing really has to, your line geometry has to be watertight. There can't be any gaps or holes in it, because once there are, I can't machine it. Or you've seen the tool path wrap around. If your tool can fit through that gap, it can wrap around and go to the outside of that geometry and come back around and try to create a closed loop. So.
And if we're doing something out of like a really expensive exotic or veneer, we will buy a few sheets of particle board and do test runs and test fits. And we do a lot more mock-up than we've ever done. So much cheaper, and especially if you have stuff that's got a long lead time. You guys know how fun it is to pick up the phone and tell somebody you're going to be 3 to 6 weeks later than you promised because you made a mistake and you got ahead of yourself.
The piece on the right there, there's just that particular piece. It was an English sycamore and Wenge bookcase, curved, but they wanted the boards to actually curve around and the grain. So that was a case where we made the bending jigs and the forms and all the basically templates for the bookcase with the CNC, and then it was old school. It was ripping the board into 1/8-inch strips and then clamping it and putting the boards back together so that the grain actually followed the bookcase around. So, sometimes you'll use your CNC to make the template to make the part. It won't necessarily be that you're using the CNC to make the parts. Go ahead, Matt.
So the one we did on this was the ceiling beam work. That from the time we literally had that land for bid to delivery was about 5 days. It was kind of one of those, if you can do this, do it, but we need it at the end of the week, and we don't care what it costs. So it's literally all just miter folded beams, and the only thing that's actual solid wood, I think, is the bottom pinnacle part. Everything else is just miter folded, laminated, slugged together. It looks way more complicated than it is. I mean, it's 3 or 4 sheets of plywood and, maybe 50 feet of solid wood.
The piece on the lower left here was all a Carpathian elm burl, and we needed to make this ring structure, usually chain linked together. The little straight pieces in between each hoop were 1/4 inch thick, and the hoops themselves, or the circles, were 1/8 inch. And we just used basically masonite, glued the veneer on it, cut the geometry out, and when we were cutting out basically the links between those chains, we actually machined it from the back side and created a pocket that would hook over the rings. In that case, we used a slightly thicker material than we needed, and then we sent it through our wide belt sander so we could basically drop those pieces out. And we on the last pass, we turned our vacuum off just because it would have sucked them all up in.
We do make a lot of positive, negative molds, if you will, to hold as basically just workpiece holding. And yeah, a lot of the stuff doesn't really need vacuum if you're using down shear. The other thing we've done is actually sandwich stuff in between two pieces and screwed it together and then machined it inside of something when it's fragile like that. And then you just basically pop it out of the mold and, you know, you basically have to make a new mold each time, but you're just talking particle board or MDF. And if you're charging for it, it's not that big a deal. You just, I don't know, it's like those little pie molds you make those things in a campfire with. It comes out good every time.
And the doors here, these were actually non-active decorative courtyard doors. There were 5 sets of them. And it's just a good study in all the different things you could do with a CNC, from making the louvered sections in the flat to doing the curved molding and the arched top rails on the radius part of the doors. The louvers were actually cut with boards where we put the diagonal slots in, and then we had a frame around the back side of it. Since it was not going to be seen, we had the advantage of being able to bring it in from the back as an assembled panel. So you'd cut all your louver slats, you'd cut the diagonal slots into a block of wood, and then it went into a rabbet in the door. Doing the louvered slots on the top radius part, I stood on my head trying to figure out how to do it with a 3-axis CNC, and I finally sent it up to the road to the guy with a 5-axis. Just because to keep that bit constant on that radius coming around, I needed a couple more turns in my machine.
We don't actually do doors, but we do components for some door shops. If you have one around you that isn't real automated, go get to know them. They'll send you some really amazing cabinet work. The types of places that have those doors have really, really good cabinet work. And yeah, a lot of times we'll cut the geometry, or we'll cut templates for them for their shapers and routers, or inlays for their panels and whatever, and they love it. It's a really good relationship to have. And this is the same thing. This was an inlay we did for a floor in a law office. And does anybody do signs? I don't know, is anybody told by a salesman, oh yeah, people are going to have you come do signs, and you're going to do wine rooms and all this stuff when you're buying a machine? There's a sign shop around the corner that we send all our work to, just because it's different, I guess. We don't have, I mean, we're not graphic designers. We don't have programs with all the fonts and things, and it just becomes a lot of work. But for the right thing, for the right price, this is a floor guy that does really, really top-end floors. We'll do stuff for him. And again, it leads us to some really nice cabinet jobs for the same people. But I mean, building signs for cabins and things, and I don't know, I would leave that to the guys with the little templates, unless it's something really special. We have done signs that we've given to customers and builders after a project, you know, like the whatever grandpa's cabin. We do a nice cabin project, we'll leave it there for them. So it's good marketing material, it's a good business card, but I honestly don't know how the production sign guys make money. That stuff is so cutthroat. If you're doing a real specialty one, you can probably do okay, but just the run-of-the-mill stuff is difficult. But they just sent their logo over, and we just flattened it, made some lines and tool paths, dropped it in there, and then we basically just glued up a section of flooring, and then they just brought it out there, and we didn't even sand it. They wanted it left raw, and then they just kind of pieced in around it, and we've made them a template for the arch so they could cut it in on site. This is what we're talking about the framing components. You can either be the framer's best friend or worst enemy. Either he feels like you're taking his cool work away, or he loves you because he's making way more money because he's getting the $5 million house done on time. This one we were on site, and they couldn't get a circle to save their lives. And the architect was like, I don't know if his string's stretching, if the screw, he's going around with the jigsaw on a string, and he's like, this isn't a jigsaw on a string house, we need help. So you can see every room had something. Well, everybody's in a hurry. I mean, it's crazy. Every room had some ceiling detail here, and the cool part is, as he said, we made the walls, so we made the curved crown, and we made all the beams and the ceiling parts. And the installers were like, this is crazy. It's going up too fast. We're losing money. It wasn't our crew. Can't even see that. Wow. We do a lot of contemporary work, not as much as Chris, but we're getting better about it. This is actually, we use a lot of bunk bed hardware to hang stuff. So again, we made the wall behind it. So it's actually plywood wall under the drywall. We had to make channels for the lighting or for the electrical and all that. But I don't know, can you guys even see that at all out there? Okay. It's basic. What's that?
Keep moving.
Okay. Yeah. It's just a box that hangs on a wall with stair treads and LED lights. It was kind of the architect's pipe dream. But it was, we make all this big stuff it's got to be able to knock down and get in the house. This was kind of what got us on that job, was this dome. They needed it to be perfect because they were hanging something, a big globe fixture in there, and it was really, really tight tolerance. If you look at the middle of the framing on there, we actually make a hub for these typically. They lost it. We think they were using it as a Frisbee, so they just coated it in PL 200. But it worked. I mean, there were alignment pieces in it, so it was straight, but then there's all the other pieces that drop into it. And take pictures of your work too, because this is stuff we show it to other people, and it drives other work. And take good pictures, not like these. This is when I was still learning.
Photograph it, they will come.
It's true. Louvers, again, this isn't stuff we go after. This is kind of change order stuff. You guys have seen that picture of the little dinghy that says original contract and then the giant yacht that says change order on the back. Yeah, when they need this stuff, they need it now. And when you're the guy who can do it and you've proven it on other stuff. So we did some floor registers for these guys because they brought us a bunch of barn wood. Well, then they wanted painted ones. And we're like, all right, so we just bang these things out in no time. And it ends up being thousands of dollars on a little tiny contract.
The curved A-crate one was kind of a fun one machining-wise. Those are all put together with half-lap joints, and basically it's taking the time to really layer your drawings so you can separate every element, and then machining those different elements in a board, basically nesting the parts together. And as you subtract pieces, depending on the type of software you use, you can actually eliminate parts, and if they're drawn right, it'll take that much material out of and that part out of it, so you'll actually create your half-lap joints. So you can actually use the geometry of the drawing to create your parts and then put them all in layers so you can go in and machine groups of parts. And we just actually had all those, the short cross pieces laid out in the radius right on a board. It would go in and cut them. And again, I wouldn't cut all the way through that board, and then I'd send it through my wide belt sander, because trying to hold on to parts that get that fine and small, you can't do it. And actually, it went together. I mean, that's unsanded. It just went together. I couldn't believe how easy it went together. But those are the kind of jobs where if I get into this 3D machining or doing these really funky things, it just goes strictly T&M as far as, it's our rate for drawing, and it's $180 on the clock on the machine runtime. So if something takes 8 hours, and you can do screen simulations, little word of caution, they're close. I find a better calculation is I know in 3D surface machining, I can process about 1 megabyte an hour. If you end up, and a megabyte file, it's a text file, so that's all the step overs, and I mean, there's a ton of machining there in a megabyte. So if you start looking at a file and your toolpath strategy, all of a sudden it spits out 24 megabytes, you have to rethink your strategy, your step overs, maybe the resolution, or having a tool made, because obviously you're not going to run your machine 24 hours and charge, $100, $180 an hour for it.
One thing I'll do to ensure profits on jobs like Leland's vent, like these other ones are overlay, but if it sits flush, I'll cut just dummy blanks out of just cheap material again and check the thickness, whatever. I'll number them, send a plan out, and I'll either courier them out, have the project manager fit them, or if it's close by, I'll run out and fit them before I actually put time into making something. And the other thing is, just by having them in the floor before my stuff comes, it doesn't get a bunch of finish in it or a bunch of garbage in it, and then something doesn't fit for some reason. But that saved me a lot of money on finished product when I've gone out to put it in, and it just doesn't quite fit, and then you're sanding it, refinishing it. We just make pieces, and if we take a little bit off, we usually prime them too, so if we take a little off, it's really obvious where it came from or which part got sanded or adjusted. So those are the pictures that got a little out of order, but this is the if you go way back to that braze-on cutter and cutting that stuff out of a sheet. No, you don't need to go all the way back. No, it's not a big deal. I think everybody remembers it. But so this was kind of how that job ended, all those little parts and pieces. It was just sheets and sheets of that stuff. So we put a few marks on the frame and some stop blocks that we put on and nail them on in place and glue them, and they're done. Just little wire pins. And I mean, once you start cutting this stuff, it's no time at all, and you don't need as much skill. So I mean, every room in this house had these things everywhere. And then the people that bought these people's old house came over and saw it and wanted to put them in this other house. So it was pretty funny. That cutter has gotten way more use than we ever expected. And then we've got some other really nice cutters we've never even used. So that's happened more than once too. We've ordered cutters and then a job goes away for some reason, and try to get a deposit on cutters and design work on this stuff. We don't show people anything or really spend any time on it without some money, unless it's somebody we're really aggressively pursuing the work and we feel like we're going to get it. Oh, there it is again. So it's just cut out of sheets rather than running moldings. It was actually, even the straights, it just made more sense to cut the straights so we could get the miters and have perfect fit. This is back to your point about the making the walls. We made the walls on this because we didn't trust people to get the oval windows in. We actually got the windows in at our shop. We made exterior and interior. We sheeted it, brought it out as a piece, and then they cut some studs out that still weren't in the right place, and we dropped it in. But basically, once we made the wall, everything else was just trickled right down. I mean, the doors, the moldings, the panel on top. It was, I think it's ugly, but it's exactly what they wanted, so.
And here going back through all the techniques we're using as far as your shaper cutters for doing that concave crown, making a bending jig to perhaps bend the top of that cabinet, your profile cutters for your cope and stick. So, I mean, you basically can start applying all the things that we've reviewed previous to this to create this whole assembly. So it's pretty cool what you can come up with.
So these were some broken pediments we did. Just broke it down into simple steps. So the front is nothing more than just an MDF routed door panel, basically, and some kerf core. And then we actually didn't run that molding in-house. We just made templates of what we needed and sent the CAD files to a molding shop that we work with a lot and stuck it all together. We could have done it all in-house, but it was just, at the time, we didn't have the time and we couldn't tie the CNC up. This guy would have literally been able to turn it faster than us. And then there were also other pediments and curved crown in the house where it made it enough of an order it was worth sending out. Next.
Actually, one of the best pieces of advice I got when I was getting my machine, guy said to me, "You're going to want to be able to do everything possible in the shop on that machine. Don't." He said, "Don't forget you got a table saw over there. If you're cutting a rectangle, it's just as fast to walk over and push it through the saw and be done."
Yeah, I feel certain we've all done it. You get the new CNC and you got to cut a bunch of 4-inch strips and, spend an hour programming it and then go cut it. And you hit yourself in the head and you go, I could have done this in 2 minutes on my table saw.
Right.
And
You forget where the power switch is, for sure.
yeah, we all have employees too who have discovered the lost art of a table saw or hand tool. Here, cut this rectangle for me. They just forget where the power switch is or how it runs.
Yeah,
It probably took me 6 months to stop
Yeah, I
that.
have to remind my machine operator that he can cut 4-inch strips of plywood.
And even,
One of the other saws.
yeah, we can still do a dado. We can still do some of this stuff.
Adjustable
You can
shelves.
do dados without,
Yeah,
wow.
it's tough, but scary.
Adjustable shelves are the
Let's
big
go to
one.
the
Somebody
next slide.
drops an adjustable shelf and it gets damaged, and they're like, "Can you reprogram this?" And it's like, grab a scrap off the wall, put it on the panel saw, and cut it.
So I brought this in for a reason too. So this looks like, to a customer, this looks like a lot. We all look at it and go, yeah, I can do that. It's not so hard. One thing you should do though is, like these really good artists nobody knows how they did what they did. You guys are familiar with the camera obscura and Da Vinci and all that. Cover your stuff up. Plug the back. Otherwise what happens is you show too many people how easy it is, and next thing you know, some guy's doing it on site. And take your stickers off if you're ordering stuff from somebody. Just cover your work a little bit. It's a good way not to get screwed over. It seems like everybody's always looking for some angle on things. So, I mean, if you're not familiar with how to build that stuff, that's how it's done. But yeah, if you cover it up and they leave them wondering. So they insisted that they site finish it. I was cool with that. So that's kind of what it looked like in process. Beadboard sheet. This was something that, I don't know, it got really popular on lake homes for a while. We were doing it all over the place. We were getting 5x10 sheets of Medex, and we were doing, that was a bit that we actually, it was a Woodtech bit. We bought it, we cut the shoulders off the top, so the depth wasn't so important anymore because it's round and overlap. That way we had no square lines anywhere, so no sanding, no surface work. So we could be off, the boards could be off a little bit. It just gained us a lot of speed. So that's something we do quite often now, is we actually relieve any sharp points on any router bits or tooling that we have unless it's necessary.
Why is that?
So you don't get a line if you're too deep or not
Oh,
deep
yeah.
enough. It just kind of fades out. Does anybody do inset beaded frames?
No.
Okay. There's a million ways to do it. There's no right way. This is something we came up with in a pinch. We didn't have a Krig machine. We didn't have a Hoffman or a Morriser or Notcher, whatever they are. So the backer piece is just a disposable piece to keep it from blowing out. The piece with the screw on it and the pencil line, that's just a registration. So pretty much all your face frames are going to be about the same, you know, should be either whatever, 1.5 inch, 2 inch, doesn't matter, but they're the same on beaded jobs. So we knew where all the, from the plan, we knew where all the haunch joints went, so we just cut them on the CNC. So this one, we cut all the lengths out and the dog ears on the ends, and then we did the haunch as another operation, just one at a time, and just moved the MDF each time. And then I told Leland about it, and then he said, I got a better way of doing it.
Is that the next slide?
Yeah. He stacks them up and does them all at
That's
once.
a video, that's a video there as well. Yeah, so this would basically, you can see the secondary spoil board with the pocket in it, and it's set up so I can do the entire kitchen at once. So
Just when you think you're a big deal, Leland calls.
And the nice thing is that, you know, you have that top, bottom, mid rail all benchmarked perfectly around the entire kitchen. And we just took the Krig face frame bits. We took the 2-inch one, and we just created a tool pass across the part and put it right in the CNC. Originally, we played around with the thought that we'd have to start handling parts because we were going to have to cut our haunches first and then put our bead on. And we actually, you'll see that these parts are already pre-beaded. The machine is so solid compared to you doing it on the Krig machine by hand or with a hand router that it just, the blowout was so minimal. You know, perhaps if it was a cherry kitchen or something really hard and tight grained, I would do the square stock and then run my bead on the edge. But I'm a big fan of running linear footage of stuff and not having to handle 500 parts on the shaper.
And we can do a combination now since seeing this. So if we have like tall cabinets that have like a tall top rail or a tall bottom rail that's different from the bases, we'll have multiple places. If you go back one, so we'll have like a story pole. We'll just write on there what it is. I mean, you can see what it is pretty quickly, but just different locations along that board, and we'll pull different programs up to do, you know, a 4 or 5 inch rail someplace, or where there's an appliance opening and it's different. So, I mean, we can do the standard stuff Leland's way, and then when we have odd stuff now, we still do it this way. Or I think we bought a little Krig machine, I guess, so.
What tool did you use for your flat cut of the haunch there?
Just a 3/8 bit.
Just a 3/8 bit?
Yeah.
What about the interior corner being rounded?
You can't even see it. I mean, I cut both parts on the machine with the same bit.
Oh, you did? Oh,
Yeah.
okay. All right.
So, I mean, instead of ripping it on the saw and cross-cutting, I just cut it all out of a big board. And, yeah, there was a little more waste, but, you know, I think I would have taken that same board over to the rip saw and done the same thing. And, you know, whatever, if it's wide enough, we'll throw it back on the pile. What's the difference? I mean, yeah, there's the joint. I mean, it's not a great picture, but the miters are, the nice part about that is the miters are absolutely perfect. There's no handwork, no fitting. I mean, you just tighten the screw and you're done. That's some of our old work. Now, this is a good friend and kind of a business mentor, does a lot of masonry work around us. And he comes to me with the crappiest jobs, but they pay well. So he's like, I need like 20 of these, and I need them next week. And he's like, I know you can do it. And I was like, I don't want to. So I brought a bunch of those pigeon crap covered things into our shop, and He just said they go into stone. They can be, make them an inch undersized. And I'm like, an inch? Are you kidding? He's like, they're like 150 feet in the air. Nobody can even see them because just make them look good. So the original's on the left, and then they redid the louvers. That's why it's shorter. We didn't screw up. So again, it's just a bunch of layers of stacked parts, but rather than wasting all that material, and then there's a cove that miters. So the trick to doing that is nothing other than just make it as separate pieces. Let it run off the end and then cut your miter and then put it together. So the piece immediately behind the profiled part is a solid frame. Everything else is just little puzzle pieces with the miters. So there's two pieces on the top part. The middle piece is one piece. The two that come up, they're separate. Basically, anywhere there's a miter, there's no fancy inside cutting. It's just a separate piece. It's just a faster way to do it. I mean, I could have done this with ball mills and it would have taken forever. This way, we banged it out in a short amount of time and we're able to get back to cutting cabinet parts. So that's what they look like way up in the air. He offered to take me up there. I said, no, it's all right.
All right, you got a half hour for this next slide.
We picked it up that much, huh?
We can go back through them again if we missed anything. So no, we wanted to leave a lot of time for question and answer because I think I've learned a few things from you guys, and the back and forth is probably the most valuable part.
I have a lot of trouble with solid wood and tear out on the timber. Is it, I mean, talking to the tooling guys, they want to, if it fits, and,
Are you using chip breakers on it, or what are you using
I
for?
wasn't using chip breakers, and that's what they told me to try and go to.
And then make sure it's just down tight. I mean, you can get vibration on the end of that board. It may not let loose, but it may still go. Do less depth in your passes too. Don't try to do it all at once.
Well, I'm kind of a less than easy way, I'll get it out first, and I can try to do one pass to get a clean cut after. I mean, I'm not talking thick material.
What species?
Cherry,
Okay. What are you trying to make, or what is it? Why? I'm trying to figure out why it's tearing out, I guess. It's just a square cut or a profile?
no, it's a radius N.
Okay.
There was someone in the building to make end tables that are radius N. So it's just,
Chip breaker will make a big difference. It really will.
Play with your feed speeds too. I mean, slow it down at that part where it's happening. I mean, we just stand there at the dial constantly, and we do keep a lot of notes on when we make a part. We take pictures of it, we print out the CAD file and put all the tool offsets and any other information.
Questions?
Over here.
Fixturing on back to the beaded inset, where you had a stack of parts where you ran the hunch all the way down.
Yes.
How are you making sure the tops of those are all dead flush and none of those are moving?
Actually, that pocket and that piece of MDF, I'd also drilled a series of holes. He was asking, how do I keep them from rocking or tipping over? And I actually came into the back edge, opposite edge of that face frame with screws into the board, thinking that most times you're either joining to another cabinet or you're hitting a wall, so nobody's ever going to see that you drilled in there. And so I actually had a series of holes in that secondary spoil board that I could screw that frame down with. So there's a little bit of setup time, but once you do your haunches, it's just zip, 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 and the whole kitchen's ready to go.
But if it's a mid-style or mid-row, we have to come up with something else.
You'd have to do, you could, depending on what it was paint grade, I guess you could use the screw down method, or you'd have to do them on a different machine by hand.
Now that I've seen that, it'll never be done by hand again. But I'll send you a picture of my fixture when I figure it out.
We go up and over sometimes too. We save some of that, like the metal and plastic strapping. Plastic's preferable that comes on your units. Yeah, I mean, we've got where we pull it through like a ratchet, and then we screw a board down, and that cinches it down. We use a lot of boards where we just screw them down at an angle, almost like a big paint stick. So if this was our part, we'd start putting screws back here until it's just got a little tension on it. Another thing, when I do those, I leave them long. I'll leave 2-3 inches on the end, and when I make that board, I'll actually cut out the pocket for it, but then I put holes through it, and then I just shoot screws in, and then when I'm done, I just slide the whole thing across the saw and literally leave the screws in, cut it right off, throw it in the trash, and yeah.
Oh, that's what you're saying, screw that entire
put a screw in each end, and then when I'm done, I cut it 2 inches off each end. I throw a lot of wood away. We're in Minnesota, we heat with it, so I don't care.
Right, and then actually in this kitchen, it had a sort of lamb's tongue cut out that we did as an applied block in the corner. So you see that big
Yeah, I gotta go
tail left at the end, and basically, I'd only take one pass with that bit, that Krig bit, and then take it to the table saw and just slice off the bead, so that I end up with my full haunch for the bottom rail.
One thing is, don't overthink this stuff. Go to the newest guy in the shop and just walk through it and say, how would you do this? And sometimes we bring our own baggage to it, make it harder than it needs to be. And I mean, I've always been that way. It's just been like, I don't know, stop overthinking it. Sometimes I just like, I do it probably worse than anybody in the shop. And I used to not be that way. I don't know what happened. I grew up and started trying to be logical.
Question, how dangerous is it to run your feet in the opposite direction in solid wood?
So basically running a climb cut. We do on solid wood sometimes. If you're going all the way around the board, you know, it's, I've never had a problem with it, but you have to be aware that you're doing a climb cut. So what could happen is it's like doing a climb cut on a shaper. You have to understand your feeder and how you have it holding that so that all of a sudden you don't take this thing and chuck a spear across the shop, which I've seen go through a steel door. So doing that same fixturing on a CNC, climb cut is definitely a machining strategy. You have an option in many CAD CAM softwares to say climb cut or standard cut. And sometimes that'll get rid of a lot of the chip out. And it might be that you'll do a standard cut going around the outside of a solid piece of wood, and we're talking about solid wood machining, and leave a 1/16 of an inch offset, and then go back in and do a climb cut on that 1/16 of an inch. And in many CAD CAM programs, that's an option. It'll say final offset or final offset, you know, for final pass. So generally it's safe as long as you understand the physics of what's going on. Yes?
Another thing on that is don't be afraid to use a left-hand cut. So if you have to cut a march, you know, climb cutting or straight cutting, you're gonna have some tear out on one side.
And you can always, I mean, the machine's accurate. You can come in and do part of it this way.
With the right hand, you cut the other half with the left hand, and you got a nice cut.
Yeah,
And don't buy a left-hand cutter by mistake and put it in a machine and say, what the heck is going on there?
we actually spray paint the ends of them pink, so you can't, you know.
Yeah, it's like, it sounds like hell when it burns things up in a hurry when you're done.
Some guys don't even notice. They just keep going.
Yep.
You're up in the office and meeting with somebody in the showroom.
I smell
You're like-
smoke.
That's another thing too we didn't talk about. We keep a couple bottles of water by our machine. I don't know, has anybody had a spoil board fire? Anybody had a bad one? I think my biggest one was about this big.
I
had
melted the phenolic.
I had a part running and I went up front and did some stuff and I smelled smoke and went out there and big black charred spot and one of the vacuum hoses was a little warm and gooey. So it happens. I mean, you should train your guys too to know what's happening and get that spoil board off the machine. Throw it on the floor and pour water on it. Don't worry about it.
Because you realize you're also pulling a nice dry vacuum through that, so once you get that ember going in there, it's very quick to get a fire going, very quick.
Yeah.
He knows all about it.
It'll get your heart pumping. It seems like it's too when you're under a little pressure as it is. Couple other things too. I mean, make sure you guys have these machines insured well, really, really well. Get full replacement insurance. It costs a little more. Keith's had his experience, not fun. Yeah, but stuff happens. I mean, statistically, somebody in this room, they're going to have a machine go one way or another. We had a spindle grenade on us a couple years ago. We have a rider on our insurance policy for any catastrophic stuff like that. It was a $20-some thousand deal. It was covered. I had maybe $1,000 deductible on it. So meet with your insurance company. Let them know. If they don't know, if you're not working with somebody in this industry, maybe talk to somebody who works in this industry or is a specialist in this or a specialist in industrial stuff. Maybe if you're using your homeowner's guy, maybe he's not the guy. Because it's when something happens, that's when you're going to feel the pain. So it's, I don't know, or what do they say? Pay buy once, cry once.
Over here?
Does anybody use aggregate at all?
No, I've played with them at other people's shops. We just haven't had enough of a calling for it. I know guys that have them, I can send stuff to them. It's just, I don't like playing with it because we depend so heavily on our machine that we've actually gotten away from a lot of this stuff. It was great when times were slow. Now we don't necessarily need to do it. So I'm actually outsourcing most of our specialty stuff now. We just don't have time to be on the computer to draw it or to be in the shop doing it.
And if you are doing aggregate work and you haven't bought your CNC, most people here have one, certainly ask about a C-axis on that machine to go along with that aggregate, if you're gonna use a lot of them.
Some other things that we do that are kind of weird is we'll actually chuck up markers and do some layout work, or basically we treat it like a giant plotter. We'll draw stuff out in CAD. And it's not common, but if we don't want to have a lot into it, but the nice thing about doing a layout that way is if something changes, instead of having, a big layout on a piece of wood, I can just go back and change it, take the cap off the marker. Caveat with that is watch your spindle speed. Everybody will have a line on them that's standing near it. So it's a good way to paint your machine if you want to do that as well. I've actually done that to lay out for like spiral stuff and to do things that I couldn't do on my machine. I've built a lot of templates for drill things to go on to things I couldn't do on there, round stuff. I don't know. Done some fun kids projects too that way. Made big posters for them out of used up spoil boards, and we try to have fun with it. And we do try to get our kids involved and younger people, give them, if we have employees too that want to make something, we'll let them. We don't really charge them machine time. They can't do work for profit on it, but some of the stuff they bring in is gold. When they want to do something, they'll ask questions, and you're like, yeah, let's do that. Just check your Z negatives and maybe do a slow run to check it. So usually we have someone else take care of their programming for them, but they'll give us the drawing.
Yeah, I think everybody that's worked for us with young kids, sort of Cub Scout age, I think we've always fired up the T-Rex model at a 1/4-inch MDF. It's 6 feet high. They love it.
Yeah, we have a couple programs for those cornhole things. The Cub Scouts will come in and cut them out and put them together. And it's a really good way to recruit people and show people what you do in your shop. My best salespeople are my machines. People see those or hear about them, and it's game on. Go ahead.
For those type of templates, is there a place that you get or you just draw from scratch, or is there a source online? I know that there are sources online that have, CAD drawings, but you mentioned cornhole boards and the T-Rex thing.
You can get them.
You just draw it yourself?
Usually we just draw it ourselves. I'm trying to kind of show, usually if I'm doing it, it's not for me, it's for someone else. So I'm trying to kind of show the process to them or even gauge their aptitude at it. If we've had like high school kids that come in and do deliveries and cleaning and stuff, and I'm like, well, let's see what you can do. And I've had some high school kids that are far better at CAD than I am, and literally you're programming, and I'm like, you're too good for this place. And they are. They leave. They go on they go to Ivy League schools, and I'm like, but it's important too. Have your local high school in. The guy before us that was this whole seminar, that's all of our futures. But I've had some really, really young guys that are super bright, and that was how I started out. I was 16. I didn't know anything, and we had a used little machine that we got, and it was just beat up. Guy couldn't make the balloon payment on the lease, so we scooped it up, and it was horrible to program, but it got me the bug, I guess. And I was actually down here when I was 21 or 22 buying a machine. Just my dad's like, I don't understand this stuff. Go get one, figure it out. And he goes, but if you screw it up, you got to live with it. So buy smart.
Chris is going to love this. I'm going to go off track with that comment about schools and showing everybody the machine. October 5th, the National Manufacturing Days. Go to your high school. Tell them about it. Tell them you're going to have an open house at your shop, and encourage kids to come with their parents and see what a modern manufacturing facility looks like. This whole perception of what our wood shops look like, and it's not that way anymore. These are modern, technological, clean places to work with good paying jobs, and not every kid's going to go on to college. So if you can open up your shop for a day, go to your local high school. It's a great way to get potential employees for the next generation in your door.
The other thing too is, I mean, keep the conversation going with us. I mean, it doesn't have to end in this classroom. You can find us on the Cabinet Makers website. We're pretty open. There's not a lot of secrets in this, and we've actually, I mean, even right now, we're doing one of our biggest projects we've ever done with another shop. So, I mean, a lot of us are pretty open about what we do. We get better, everybody gets better. We all raise our prices and make more money ideally. So it's good to know, I mean, to have those conversations with people. I mean, instead of having these secrets behind closed doors, there really aren't that many secrets. So, and, I mean, if you have that, put it away when someone comes over, big deal. But,
So there's not everyone's from college, but there are some colleges that do have programs that you have to correlate the CNC machine, you know, the types of machines that are in the modern shop.
Right.
That's good.
It's definitely, I see an uptick in tech schools and non-traditional secondary schools. There's several, Virginia Tech here, North Carolina State's here.
I
So,
came in from the software end. I mean, I was in software. It's the only machine that they let me use. I don't have.
yeah, I mean, in a lot of ways, it's the safest machine to start somebody on too.
yep.
One other thing too, and I learned this from Chris, if you photograph it, they will come. And even though it seems mundane in my working on this, trying to find pictures, I couldn't find pictures of a lot of stuff I thought I had. Take pictures all the time, take videos, put them on Instagram, put them on your website, your Facebook, whatever. People love that stuff. They're not necessarily buying for price or what you can do. It's emotion. They're saying, I want to be a part of this cool thing these guys are doing. You know, let these machines do more work for you. Let them be salespeople. You don't have to pay them a commission. But get that stuff out there and people just eat it up, especially when you got the fixtures and stuff. Don't worry about some other shop seeing it. I mean, it'll also attract.
And to that point, don't photograph it if you don't want to do it again.
Yeah, that's true.
We've generated quite a bit of, realistically speaking, my work is, I don't know about you all, we don't advertise very much. Realistically, it's coming from GCs, contractors that we've been working with for years and years.
We've brought in employees with it too.
Right.
They see what we're doing and they're like, you know what? I'm sick of what we're doing.
We got a young guy in, and he's like, you guys should really have a Facebook page. We got a website that's meant, and he's like, you guys really need a Facebook page. So we started a Facebook page, started requesting that, go to a job site or whatever, out the shop, get something large item assembled. We take pictures, we put it on Facebook, and it's amazing, even in town, I stop in the store and I'll get, hey, I saw that cabinet, that was cool, and we've actually generated local work for local residents, which we never did before.
Yeah, I mean, you are your brand, so you might as well rock it. Go ahead, Jim.
Just globally speaking, light machine versus heavy machine and capabilities. For instance, Leland's got a very large, powerful machine, whereas Chris's machine is a little bit more lightweight. As far as a lot of things that you've seen today, we find most machines can do most activities because it seems to be, there's a large price comparison on the floor. You've got different size spindles and that sort of thing. Based upon the majority of what you do, do you find if you're sticking with basically 3/4-inch material and those things that, what is the break point as far as capabilities inside of the machine?
I think you get into speeds. What can you do? Feed speed, and I mean, my spindle is 5.5 horsepower. It's fine for cutting 3/4-inch plywood or MDF or particle board or whatever, and that's 99% of what crosses the bed of that thing.
Could your machine do a 5-inch thick mahogany post?
Yep, it might take it longer. We just have to take smaller passes, but we could do it. I don't think I would do that. I mean, I would not do that because that's not the kind of work we do. But for us, we're a very contemporary shop. 90% of what we push out is a slab door that's either an acrylic panel with laser edge on it, or it's an MDF panel that we paint. And I don't need a whole lot of extra stuff. We're also not a high production shop, so if it takes longer to run it on the machine, we just walk away and do something else.
You could put a bigger bit in if you need more feed speed too, to a point, and then eventually you're taking off so much material, it's gonna wear down on your spindle. But to your point, I mean, my machine, the replacement value is a little over 200,000. I'd if I went home today and my shop wasn't there, I'd probably go buy 4 or 5 of Chris's machine, or 2 of them. And that way I have redundancy, and it's like, well, I got 2 machines running at 3/4 the speed of my old machine, so now I'm 1.5 times faster. And then there's a lot of ways to look at it. I could have the machines stacked up on top of each other and have a mezzanine. There's a million ways to do it, but
I mean, basically a correlation of weight, you know, if it's a stamped steel bolted together frame on a super light, piece of CNC machinery with a, you know, quarter cable router on it, or whether it's a 10,000-pound cast iron base on it, it's gonna be how fat, it's gonna be repeatability, you know, the accuracy. If that gantry is flying down and you're moving in the X and Y axes and you're driving a 1/2 inch or 3/8 bit through 3/4 of an inch, the lighter that frame is, the more you're gonna start to get some torque, right? Because there's forces there. If that machine is bolted solid and 10,000 pounds of cast iron on the floor and it's leveled, it's gonna take that and it's gonna drive that bit through the material, and you're gonna be able to come back to that same tool path 20 times and you're never gonna hear it touch the material again, because it never got that flex in it or that torque, and that has a lot to do with that mass that your machine has, weight.
James McGrew's not in here, is he? That guy buys CNCs and takes them out to commercial job sites to use them, specific for jobs. He had a big contract with Amazon to do solid surface tops, so he ordered a specific machine from Cammaster, I believe, and had it shipped to their warehouse, and he was fabricating on site because the tops were too big to transport. So that's something, I mean, that is, to your point, Jim, if I got smaller machines, I could literally move them around I could pick them up with the forklift with some extensions. I can't do that with what I have now. I could throw one up on the shelf if I'm not using it for a while. I could reconfigure the shop literally daily for what we're doing. So, I mean, and I way overbought though on my machine, and it's 15 years old and it's still completely relevant and rock solid. The only thing that's really becoming an issue now is the computer. It's just getting so old, and it's got an integrated motherboard and a screen, and it's just old computer stuff. We all know how fun that is to deal with. So,
Yep.
What are you guys willing to pay your highest skilled operator?
For me currently, it's $30 an hour. And in this market, I'm probably overpaying.
yeah, we're probably in the low to mid 20s, but we're heavier on the benefits too. We offer some pretty serious benefits to people, so it's, I don't know.
That's where we're the mid-20s, and we don't have benefits, unfortunately.
And the other thing is, our guys, if they're a good operator, they're gonna move up into drafting and design work and meetings and things too. So it's not just about the dollar today, it's about where's the potential for growth. But, for us, it's a challenge too. We compete with a lot of shops that maybe pay their guys $1 or $2 more, but have zero benefits. So we try to get people who understand the value of a benefit versus $1 today. Yeah, and I mean, it comes down to your cost of living too. I mean,
Oh, you're Georgia, Minnesota, and I'm New York.
Minnesota, we have a high cost of living just due to, we have to have so much insulation and furnaces and AC, and it's just expensive to live where we live.
Beer more expensive?
Beer? According to my wife, it is. Should be less? I don't know. I think it's about the same everywhere.
Any other questions? Thank you, everybody.
Thank you, guys.